Chapter 5, Section 1 is Exponents and Scientific Notation. We've covered exponents a little bit back in Chapter 1, and we talked about the large number is called the base, the little number up top is called the exponent or the power, and what that means is take the base times itself, the number of times that your exponent says. And I did want to just remember, I wanted to remind you that if your base is in parentheses, then it's the whole base that's taken that many times, and if it's not, then it's not. So in this case, this is -4 times itself 4 times, and because there's an even exponent, we're going to have an even number of negatives, so that's going to make it a positive 256. Whereas in this case, we're going to take the 4 times itself, and that's 256, but we want the opposite of that. We want the negative, so we want negative 256. So that's just a little reminder. We've done that before, but just to remind you. So the new part for this section is anything to the power of 1 is itself. So if I have 6 to the 1 power, it's 6. 582 to the 1 power is 582. 3 to the 1 power is 3, and so forth. If you have anything to the 0 power, it's 1. So whatever you have, 8 to the 0 power is 1. If I have 9 to the 0 power, it's 1. If I have 82 to the 1 power, it's 1. So to the 0 power, sorry, did I say that every time? To the 0 power is 1, because that means we have zero factors of 8. So we just have a 1 sitting there. Okay? If we have a negative exponent, what we're saying is we're going to, it's almost like we're dividing that many times. So a negative exponent flips that number down into the denominator. So a -3 to the -4 power says I want 1 over -3 to the 4th power. So that's going to be 1 over -3 times -3 times -3. So all of that is in the denominator. So 3 times 3 is 9. 9 times 3 is 27. So 1 over 27. And we have an odd number of negatives. So it's 1 over -27. And that's the same as just -1 over 27. It's the same either way. Y to the -5th is 1 over y to the 5th. When we flip it down to the bottom, now it becomes a positive exponent because we've already changed that. So this is going to be -2 to the -4th power. So we're going to have -1 over 2 to the 4th power. So 2 to the 4th power is 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So you have 1 over 16, but the whole thing is negative. So -1/16. All right. 1 over 3 to the -4. Now, if we have a negative exponent in our base, or in our denominator of our fraction, that's actually going to flip it up to the numerator because it starts out in the bottom, and so a negative exponent is going to flip it to the opposite. So now we're going to have 3 to the 4th power, and this is 3 over 1, and anything over 1 is itself. So 3 to the 4th power is 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. And now our last example, if you've got a fraction to the -1 power, well, that's going to move the numerator down to the bottom, and it's going to move the denominator up to the top. So it's just going to flip it. So this is saying I want the inverse of a over b. So you just flip the whole fraction. So once you've done that, then you take the whole thing to its power. So watch this. So -4/5 to the -3 power, it's going to be -5/4 to the 3rd power. You see what I did? So in order to take the negative off, and so that we don't want the inverse, we're going to invert the fraction. So the 4/5 becomes 5/4. Everything else stays the same. The only thing we've changed now is that we've already inverted it, so we don't have our negative exponent. So now if you'll remember, back from section 1, this 3rd power is on the whole fraction. So you can either take 5/4 times 5/4 times 5/4, or you can just take the 5 times 5 times 5 over 4 times 4 times 4. It's exactly the same thing. So it's just however your mind sees it the easiest. So 5 times 5 times 5 over 4 times 4 times 4 So 5 times 5 times 5 is 125. And 4 times 4 times 4, 16 times 4 is 64. And let's look back and make sure, aha, there was a negative on that as we went, so don't lose the negative. So your final answer is a negative 125 over 64. All right, so it's a lot the same thing you already did, except that 0, anything to the 0 power is 1. Anything to the 1 power is itself, and these negative exponents are going to flip. So if the negative exponent is in the numerator, it's going to flip down to the denominator. If it's in the denominator, it's going to flip up. And if you have both, it's going to flip them. All right? Okay, so that's all on exponents. That's all we've got on exponents. The next thing we have is scientific notation. And that's in this section because scientific notation has to do with exponents because if you'll remember, excuse me, for a number to be in scientific notation, the whole purpose for scientific notation is to be able to write very, very large numbers or very, very small numbers. And the reason we call it scientific notation is because scientists use it a lot because they're the ones dealing with huge numbers and tiny numbers most often. So a number in scientific notation is a number between 1 and 9. And the way I remember that is just it's one number in the ones place, point, and then whatever's left is after that. So one number, a number between 1 and 9 times 10 raised to a power. And the reason you're going to raise that to a power is to get it back to its original number. So let me show you. Let's see if we've got 4.6 times 10. What we'll do first is I'll give you a couple of numbers. These are in scientific notation already. So what we're going to need to do is we're going to need to take numbers that are in scientific notation and be able to change them to standard form. And then we're also going to need to take standard numbers and change them back into scientific notation. And now if you already know how to do this and you want to pause it and just do them on your own, you just feel free. I need new markers. They're dying left and right. All right. I should have written this out on something else first. Okay. Now, hopefully you've done a couple of these already. So what we need to do is these numbers up here, up to here, are in scientific notation because if you see the first number is between 1 and 9, so it's a number in the ones place, point, and then the rest of the number, times 10 raised to a power. Anytime you raise 10 to a power, you're just moving the decimal because 10 to the 6th power is a 1 with 6 zeros, and if you multiply that, you're just going to add 6 zeros to the end of whatever it is you're multiplying. So what we're going to do is we're going to move the decimal 6 places. So that's what happens when you multiply by a power of 10. So to change this scientific notation to a standard number, we're simply going to move the decimal from where it is to the right 6 places. So I usually just write out the number 46 and then find where that decimal was, and you're going to move it 1, 2, 3, 4, 5, 6, and then fill in the little swoopies with zeros. And don't forget to put your commas because that makes it easier to read the number. All right, do this one on your own. Quick, pause. You got it? Okay, here we go. So 8, and the decimal is here even if you don't see it. All right, the decimal is at the end when you don't see it. And so we're going to move the decimal 7 places. And when we move it 7 places, since there are no other numbers, we're simply going to add 7 zeros. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, and put in your commas. Easy sneezy. So now, if you've got a negative exponent, what happens when you multiply by a negative exponent? That's the same as, 10 to the negative 1 power is the same as 1/10. And 1/10, if you multiply by 1/10, it actually moves the decimal to the left. So if you're multiplying by 10 to the negative 6, what you would do here is write out your 724, and your decimal started here, and you're going to move it backwards. 1, 2, 3, 4, 5, 6. There's your decimal. 1, 2, 3, 4, 5, and you don't have commas that direction. They're harder to read. All right, and you're done. All right, do one more this time. Start with a 5. We move the decimal. Make sure that you start that decimal at the end. If you don't see it, it's always at the end. So here's just a tip. If you're going to the left, you're always going to have one less 0 than you have in your negative power, because you've got to move the decimal one place over for your whole number, but then the rest are just going to be zeros. So we're going to have 1, 2, 3, 4, 5, 6, and a decimal. That won't necessarily work the other direction because sometimes you have numbers after the decimal and sometimes you don't. All right, easy sneezy. Now let's change standard numbers into scientific notation. That's just as easy. What you're going to do is we're working backwards. So step 1 is we need a number between 1 and 9. So simply take the digits that are not zeros, the non-zero digits, and you're going to write them out. 603, and you're going to put the decimal where you want it. You want it so that you just have one number to the left of the decimal. So once you put it there, you're going to say times 10, and you're going to count the number of places that you've got to move to get back to where you started. So your decimal is now here, and you need 1, 2, 3, 4, 5, 6, 7, 8 places. So it's going to be times 10 to the 8th power. All right, if you got it, move on. If not, do it with me. Here we go. So 9.25 is going to be your non-zero numbers. 9.25 times 10, and you're going to count. You need the decimal to be right here. So there's 3, 6, 9, 12, 13 times 10 to the 13th. Not so bad, right? Okay. Now you're going the other way. So if it's a very, 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 very small number, you know that your exponent is going to be negative. So put your numbers exactly where you want them. 1.72, put your decimal where you want it in your non-zero, and then times 10. And you got to figure out, well, what power do you want? Well, you know it's going to be negative because you're moving that way. Times 10 to a negative power, and you just count them. So you've got to move 1, 2, 3, 4, 5, so it's a negative 5 power. And remember, if it's negative, you can count your zeros and add 1. All right, last one. Same thing, 9.034 times 10. It's going to be a negative number because it's very, very small. 1, 2, 3, 4, 5, 6, 7 zeros. So it's going to be to the negative 8 because we've got to get it past the non-zero number of 9. So negative 8 is our exponent. Easy. So that's all you're going to be doing today. You're going to be evaluating exponents with negative exponents, so be careful to move them up or down depending on where they started out. And then scientific notation, you will have numbers in scientific notation you'll need to change to standard form, and you'll have standard numbers you'll need to change to scientific notation. Easy sneezy. See you soon.